This mini lecture is going to be dealing with the different types of arrays that are possible using ADA. So the first thing is you'll notice what we had last time. Your typical declaration of an array that is a fixed size and contains values of a certain type. And then to actually create one of these, we then have a name of that particular type. So this is what we know is a fully typed array. And if you want to be safe, you can obviously have a array size variable that is say a constant natural, and then you would have array size stored there. Now the purpose of going through and using these three lines to create an array is now we can pass this to procedures and functions. Whereas if you use the syntax as we have here, it is not possible to pass values to, although I can say values 1 to be 5, and I can say values 2 of 5 or 1 can be 5 as well. And as we compile this, helps if you accidentally have the right information for a constant. Sorry about that. And as we can see, both of these work, but the problem is values 2, very easy to declare. I just say it's an array of size 50 of integers. However, I can't pass this to a function because, actually let's use a procedure because I don't need to return this. I just test is. Actually need to pass in. So if I wanted to pass in an array, well, I would say, well, let's just say data of type array type. So this makes sense because I have to specify what type I'm passing in. However, this array 150 of integers, well, that's not a type, that's a shortcut. This is what we call an anonymous array. So if you just need an array for a few temporary calculations and you don't want to go through and create your actual type, that's one of the things you can do. Now, one thing you may be asking is, since you saw some declare blocks, how can we actually apply those to arrays? So in this case, instead of declaring a new string of a particular size in a declare block, now what we're going to do is let's get the size of whatever we want the array to be, and then let's use a declare block, and I'm going to say my new array is my array type from 1 to size. And we'll need to begin. And let's say new array of 1 equals 5. So now, when I run this, it asks for the size of the array, and although the range is unknown at compile time, we know the particular type, and we will go through, and whenever we instantiate or create a variable of the myArray type, we are forced to give it a particular range. And it is okay to do this because we have our particular type and we are passing it, or can pass it back and forth to procedures and functions because we know the type. Whereas this is not a type, this is part of the declaration of a type. So our declare block allows us to send different sized arrays, which can cause some issues, and that's why it's important to understand that statements for looping, such as new array of range, so I wanted to go through every element, I would say for I in the new array's range, and then we could go through and loop and set new array of I to be I. So obviously we're creating an array of this particular size, and let's just go ahead and output I just to verify that it is whatever number I type in. So it does go through and create the array of whatever size that we type in. So whenever you're using this and passing it to procedures and functions, it's doubly important to use the range qualifier when you're doing this. And also if you're comparing arrays with an if statement, you need to make sure that the sizes are the same, otherwise your comparisons are not going to work properly. Or if you're comparing information from a larger array and a smaller array, you have to constrain the larger array so that you can compare the values between them. So this is an example of how you can use arrays in a dynamic manner in Ada.